The first feature we are going to talk about, which is in Swift 5.3, is the multiple trailing closures. So you can see that I have a function over here, and this particular function takes in a URL as a string, and then it has two different closures, the closure for success and closure for failure. Now, in Swift 5.2 or earlier version, I can simply go ahead and call the load function. I can pass in some URL. It doesn't really matter what you're passing. And then the success, I can implement it kind of like this. So I can say here, and I can say get the data, and I can do something with the data. And for the failure, I can do the same thing. I'll get the error, and I can do something with the error. And if you build this, that will be perfectly fine. Now the same thing can be written in Swift 5.3 with the multiple trailing closures. So I'm going to go ahead and call the load function. I'm going to pass in some URL. And for the success and for the failure, you can see that now these are both trailing closures. So I can write some code over here for the success part, and I can write some code over here for the error part, which is the failure. So you can see that the function actually finishes right at this particular moment, and then we have a trailing closure, the first trailing closure, which ends right here, and then the second one, you have to provide a label over here. If you don't provide a label, it's not going to work. So the failure label, and then the second one comes over here. So you can have now multiple trailing closures in Swift 5.3. Another feature that Swift 5.3 is introducing is the multi-pattern catch clauses. So let's go ahead and take a look at an example. Over here in this example, we have a network error enum, which consists of the failure and a timeout. And we have a function called load something from network, which can actually throws. And then we try to call load something from network, and you can see that we have multiple catch clauses to handle each case. Case for the failure, case for the timeout, and a generic case for everything else. So in Swift 5.3, what you can do is you can catch multiple things. So network error, and you can also say network.timeout. So you don't really need a separate case for that. You can simply catch it, the failure as well as the timeout. So this is one of the new features of multi-pattern catch clauses in Swift 5.3. All right, let's move to synthesize comparable conformance for enum types. So what does that mean? Well, this means that now enum types can be comparable. You can compare them, you can sort them, and all those kind of equality operations, or comparable operations actually. So let's say that if we have an enum type membership, and this is comparable, so I'm just going to say comparable. And we have few cases, so I'm just going to say premium, and this example is actually taken from the actual proposal itself, and we're going to start with preferred, and the final one is general. Now, the way that the comparable conformance work for enum is that the order in which they appear. So this one, the premium, is the lowest order, meaning 0. This one is like 1, and this one is 2. Now, if I am, since you can see that this one, premium, does actually take an argument, first it will be compared against the actual 0, and then 0 will be less than 1. So depending on the argument that you're passing, the argument will be compared next. So let's take a look at a very simple example. If I have an array with mixed values, so if I have an array which has preferred, so I have over here membership preferred, so I'm going to create an array, and I'm going to just say membership dot preferred. So that's the first one I have, and then the next one I have is membership dot premium. Now in the premium, I'm just going to pass in 0, and I have another one which is membership dot general. And then we have membership dot premium again, but this time I'm going to pass in 1. All right. And if I can go ahead and say maybe like sorted. So what would it actually print out? So if we run this, it's going to basically allow us to, it's going to return something, which you can see the call of sorted is unused. But if you run this, the actual result would be the first one, because you can see the premium. But which one should we choose? Should we choose the premium of 0, or should we choose the premium of 1? Well, the 0 is going to come first because the argument value is actually less. So this one is going to be the first one, followed by the premium of 1. So I'm going to take this one. Then, according to this sequence, it's going to be the preferred. So I'm going to go ahead and get the preferred one. And the final one, obviously, is the general, because in that order, it comes at the end. So this is the synthesized comparable conformance for Swift. This means that your enum types can now be comparables. So you can sort them ascending, descending order, whatever order that you want, and you can perform all kind of those less than equal to kind of operations. Our next change allows us to not use self explicitly, and it's not really required everywhere. So a very good example is the SwiftUI views that you're building. And one of the things that you will note is that I have to use self.isClicked because it is currently inside the closure of the button. Now with Swift 5.3, you don't really have to say self. You can simply say isClicked, and it's going to work just fine. So you don't really have to use self explicitly, and it's not really required everywhere. Having said that, I do have a habit, personally, I do have a habit of always putting self, because whenever I use self, it always tells me that this particular property is defined at the class level, meaning it's a property of the class, and it's not really some object or a private variable. So I personally actually always use self. That's just my habit. But for you, if you don't like putting self everywhere, you just want it to work, then you can simply use that. You will be able to use that in the future when Swift 5.3 is actually released. So this is actually a pretty cool feature, which means that you can use where clauses on a generic declarations. I have a protocol over here, which is the electric type. And if I want to create a function, so I will say charge, I can pass in the type. I can say the car type, where type is actually electric type. This means that only thing that you can actually pass to this particular charge function is type T, which is a generic, and which should belong to, or which should be conforming to, the protocol, which is electric type. So this is very, very cool, and I think very, very useful whenever you are using generics and you want to add some constraints on the generics, that the constraint on the function, that the actual thing that you're passing in has to be conforming to some protocol. So that's very, very useful, and I think it's going to come really handy. If you want to support my channel, then the best way would be to check out my courses on Udemy. I have a lot of different courses. This is my latest course, which is Testing iOS App, Behavior-Driven Development using the Swift language. This course covers everything you need to know about unit testing, test-driven development, and behavior-driven development using iOS, using Swift. It's an amazing course, but if you're interested in different courses that I have, then you can always check out my profile page on Udemy, and you will find many different courses, including course on SwiftUI, including course on machine learning, artificial intelligence, MVVM design pattern, RxSwift, Combine, ARKit, and much, much more. Thank you so much, and if you have any questions and comments, let me know. Make sure to share this video, and also make sure to subscribe to the channel and give me a thumbs up if you like the video. Thank you so much.